Hello, my name is Justin, and today I'm going to show you how to make prime numbers using Scratch. So a prime number is any number, positive number, so that's a number that's 1, 2, 3 or larger, that is not evenly divisible by any number other than 1 and itself. So if it's only evenly divisible by 1 or itself, then it's prime. And what does it mean to be evenly divisible? Well, 4 is evenly divisible by 2, because if you do the long division here, you can see 4 divided by 2, that's 2, that's 4, you get 0. So that's 2 remainder 0. So that is evenly divisible. 4 is evenly divisible by 2 because it has a remainder 0 at the end. 5 is not evenly divisible by 2, because if we did the same thing, here we get 2 minus 4, get 1, so that's 2 remainder 1. So since the remainder is not 0, 5 is not evenly divisible by 2. A prime number is a number that is only evenly divisible by 1 and itself. So let's say 2 here is evenly divisible by 1 and 2, because 2 divided by 1 is 2, and 2 divided by 2 is 1. 3 is a prime number as well, because it's only evenly divisible by 1 and 3. 2, it's not evenly divisible by 2 because that would be 1 remainder 1. 4, however, is not prime because it's evenly divisible by 1, 2, and 4. Since this 2 is here, since 4 can be divided by 2 and have no remainder, it is not prime. So 4 would not be prime. 5 would be prime because it's only divisible by 1 and 5. 2, 3, and 4 cannot evenly divide it, so that is prime. 6 would not be prime because it's evenly divisible by 2. 7 is prime, 8's not prime, 9's not prime, and so on. So we're going to use Scratch in order to compute these prime numbers. And we can do that by simply taking every number and checking every number before it to see if it's evenly divisible by that number. If it is evenly divisible by another number, then it is not prime. If it's not, if we can check every single number before it, and it's not evenly divisible, then it is prime. Now, 1 is not prime, because it's only evenly divisible by 1. You have to have at least 2 factors here, like 1 and 2. Since 1 is only evenly divisible by 1 and 1, it is not a prime number. So 1 is not prime. Neither is 0, or any negative number. Those are not prime numbers. So let's get started here in Scratch. We can get our when run button clicked to start out our program. And in order to store all these numbers, we're going to need a list, because a normal variable can only store one number. But here in Scratch, we can delete this variable here. We can make a list, and this list will store multiple numbers. So let's name this list primes, and this will be our list of prime numbers. At the beginning, we're probably going to want to delete all of primes to make sure primes is completely empty in case we want to run this multiple times. And then we're going to have to ask the user how many prime numbers we want to make, because we can't just keep making it forever. We need to know a way to stop. So let's ask how many primes. When we run it, it'll pop up with this dialog box here, and we can enter in and say 10 primes, and it would store that value here in this variable called answer. It's specifically for this ask block. Now we need to start making our prime numbers. Remember, the prime numbers start at 2. So we're going to need some way of keeping track of what number we are on. So let's make a new variable here, and let's name it number. And this will be our current number. And remember, we start out at 2, because that would be the first prime number. Then we're going to keep looping, keep checking every number until we have however many numbers you enter. And we can do that using this repeat until. So this will keep running all the code that's inside until we tell it to stop. And in order to tell it to stop, we're going to say equals here. And we want to say the length of primes, so the number of primes that we have, is equal to our answer. And so if we tell it we want 10 primes, then primes should be full with 10 numbers, and then it'll stop. Now we want to check our current number, see is it prime? If it is, we'll add it into primes. If not, we'll just increment it to the 3 and move on, and then we'll check 4 and 5 until we have enough primes to stop. Now, in order to check if a number is prime, there's many different ways to do that, but we are going to check every number before the number, all the way down to 2, and see if it's evenly divisible. If it is, then it won't be prime. If it is not, then it will be prime. So we can add in another loop here. We can repeat it. And we are going to need to make a new variable here to keep track of what number we're dividing by. So we have one variable that's keeping track of, say, our 5 here. And we need another one to keep track of 2, 3, 4, all the way up until we reach 5 to see if it's evenly divisible. So let's make a new variable here. And we'll name it divisor, because that's the one we're dividing by. And we can start out in here with our divisor set to 2. And this is starting to get a bit cluttered. So instead of trying to fill this up with multiple different loops inside of loops, we can add in what's called a new block. So we can press make block here, and this will add in a new section which can run. And what we're going to do is we're going to have this block check whether or not the number is prime. That way, instead of having to add all of it in here, we can do it in this block over here, and it'll be easy to see. So let's make this new block, and we'll say is number prime. Okay. And now you have this bit here where you can start defining what is number prime means. And then you can add in this block, put it here, and it's essentially just copy and pasting this over here, but it's a lot easier to see and understand what's happening. This is a common idea in computers and coding. It's called abstraction. It makes it a lot easier to understand what's happening, so you don't have to save in your mind exactly how everything's working. You just know that this is going to check is the number prime. So we have to check every single one of the numbers before our current number and see if it evenly divides it. In order to do that, we're going to make one more variable, and we're going to name it is prime. And we can say, at the beginning, just assume that it's true. Then we check every number. If it's not true, if it evenly divides the number that we're looking at, then we will change is prime to false. But if it can make it through every one of these numbers and not be evenly divided, then it should be true. So we will have to check every number from divisor up until our current number here. So actually, instead of a repeat here, we're going to change that out for a repeat until. And we'll add in equals here, so we can check if our divisor is equal to the current number and then stop. Divisor is equal to number. And then once we make it through here, whatever is prime is the answer over here. So now in order to see if a number evenly divides another number, we need to check the remainder after division. And that is done with this mod or modulus. It tells you the remainder after division. So we can put in number and divisor, and it'll tell you the remainder if you did number divided by divisor. So, for example, 5 mod 2 would equal 1, because that's the remainder after you divide 5 by 2. Now when the remainder is 0, then we know it evenly divides, and so it is not prime. So we can add in our if block here. We can say if our remainder here, number mod divisor, is a 0, then is prime should be false. We can set is prime to false. So this little block here is this entire code block here. It's essentially just copy and paste it, but it's a lot easier to see what's happening. Now, after we check if our number is evenly divided by divisor or not, we have to make sure that we increase our divisor here. That way we check every number. So we need to set divisor equal to, divisor plus 1. This makes it so we're not just checking 2 every time we do 2, then we check 3, then we check 4, until we reach 5, and then we stop checking. Now we can check if any number is prime. If it is prime, so we use an if block here, so if is prime, our variable is prime, is true, then we want to add this number to primes. Add number to primes. And then at the end of this, we need to make sure we increase our number, so we start checking the next number to see if it's prime. So we can set number to number plus 1. So when we run our program, it will empty out primes to make sure it's an empty list. Then we will ask how many primes we want from the user, and the user can enter in how many primes they want. And we start out at the number 2, because 1 or 0 or any numbers less can never be prime. So we start out at checking 2. And then we want to repeat this. We want to keep checking numbers to see if they're prime until we have however many primes the user entered. Then we want to check and see if the current number we're at here is prime. That's what this block does. That way we don't have to put this entire block in here and make a big mess. It's that, as you can see, is really hard to understand what's happening in here. But with the abstraction, we can take that code out, put it over there, and we know that all we're doing is checking is the number prime right here. We can go over here and look at how is number prime works. We start out by just assuming that it is prime, and then we want to check all numbers up to it using divisor here to see if it evenly divides it. So we check until we've reached our current number, and if our number is divided by our divisor with the remainder is equal to 0, then it can't be prime, because then it's been evenly divided by a number other than 1 and itself. And that's what mod here does. It tells you the remainder after division. And then after that, we just increase divisor so that way we check every number up until the current number we're looking at. And that'll return either true or false if is prime. It'll return is prime is either true or false with whether or not our number is currently prime. Then we can check if our number is prime. If it is, then we add it to our list of primes. And then we have to increase our number to keep checking the next number and the next number and so on until we've reached enough primes. So hopefully, if we run this, we can ask for a number of primes. We can say 10. And this should give us our list of primes. Now we can output the primes. We can have our sprite say it by going to looks and say. And then we're going to need some join. That way we can put multiple sentences together. We're going to need a few of those. And we can say the first, and then however many primes we wanted. So for example, 10 primes are, and then we can put in our list here, primes, and our sprite should say the list of primes. If we run it again, ask how many primes, let's say the first 10 primes, and there you go, the first 10 primes, 2, 3, 5, 7, 11, 13, and so on. And we can just double check to make sure that's correct and say first 10 primes, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. So that is correct. And if you wanted to say even more primes, say 100, well, that's too many primes to say here, but you can look at your list of primes here to see all of the prime numbers there. And that's how you can list prime numbers using Scratch.